Hello students, welcome to Engineers Academy. Kindly subscribe my channel for such more problem solutions. Now let's solve this problem. In this problem we are given the uniform 18 kg bar OA is held in the position shown by the smooth pen at O and the cable AB, and we are required to determine the tension T in the cable and the magnitude and direction of the external pin reaction at O. Right, so if we represent the tension T in this cable, so that will be acting from this point A to that B, right? So this is the tension T which is required to be determined, and then the reactions at O are required to be determined, right? So let's say that this is the reaction in the X direction, right? So let's say this is OX, and let's say this is our positive X and positive Y direction, right? So let's say that this is our reaction in the Y direction, right? So we will name it OY, right? So we will find the magnitude, the total reaction, the resultant reaction at this point O, right? And if I draw a line, a horizontal line here, so then this T force will be making some angle with this horizontal line, right? So let's say that this angle is theta. So if this angle is theta, so then this angle is also theta, right? So first we will determine this theta. For that I will draw a triangle. To find this theta we will use this triangle, this red triangle, right? And let's say that this point is, let's say, C, right? So we will consider this ABC triangle. So to find this theta, if we apply tan theta to that ABC triangle, so tan theta will be equal to this AC, so AC divided by this BC, right? So from this triangle, as we can see that we are given this OA length, right? And this OA is making 60 degrees, right? So this means that this AC is equal to the sine component. This is the sine component of this 1.5 meters if we consider this AOC triangle, right? If we consider this triangle, this small triangle, so let me complete this triangle as well, right? If I join this, so from this triangle, this AC is 1.5 sine of 60 degrees. This is 60 degrees, right? And this OC is this length. This OC length is the cos component of 1.5, so this is 1.5 cos of 60 degrees, right? So this means that this AC is how much? So this is 1.5 sine of 60 degrees divided by BC. So BC is equal to this BO. We can write that this BC is further equal to BO plus this OC, right? So we can write that from this equation we can say that theta is equal to tan inverse, and this 1.5 sine of 60 degrees divided by BO, which is 1.2 meters. So you will write 1.2 plus OC. So this OC is 1.5 cos of 60. So this is 1.5 cos of 60 degrees. So from this we get theta equals to 33.7 degrees, right? So now we know this theta, which is equal to 33.7 degrees, right? Now if we represent the weight of this OA bar, so the weight of this OA bar will be acting at the midpoint of this 1.5 meters, right? So let me represent the weight of this OA bar, which is the mass of this OA bar is 18 kg. So if we represent the weight, so that weight will be acting somewhere here, right? And let's say that this is that weight, and this weight will be 18 into 9.81, right? And let's say that this is the point G, the point of application of this weight, right? The center of gravity of this OA. So this OG distance will be 1.5 divided by 2, so this will be 0.75 meters, right? And similarly this GA distance will be again 0.75 meters. So now since we are required to find this tension T, So if I resolve this tension T into its components now, so it will have one component in this direction, right, and it will have one another component in this direction. So this component is the cos component, so we can write that this is T cos of theta, and theta is 33.7, so you will write that this is 33.7 degrees, and this component is the sine component, so you will write T sine of 33.7 degrees. And now if we apply the summation of moment at point O equals to 0, since the system is in equilibrium, and if we consider that the counterclockwise moment is positive, so now as we can see that this cos component is producing the counterclockwise moment about this point O, so we will write plus, and this will be T cos of 33.7 degrees, and the perpendicular distance of this cos component from that point O is equal to this AC, right? This is the perpendicular distance. So this is 1.5 sine of 60, right? So this is 1.5 sine of 60 degrees. Similarly, this sine component is producing the clockwise moment about this point O, so we will write minus, and this is T sine of 33.7 degrees, and the perpendicular distance of this sine component from that point O is this OC, which is the cos component of this point 1.5, right? So we can write that this is 1.5 cos of 60 degrees. And now as we can see that this weight of this OA bar is producing the clockwise moment about this point O, so we will write again minus, and this is 18 into 9.81, and the perpendicular distance of this weight from this point O is this distance, right? If I represent this, so we are having this distance, right? So if we consider this small triangle and this OG length is 0.75 meters, so then this will be the cos component, right? So we can write that the perpendicular distance of this weight from that point O is this distance, right? If this is OG, so then this distance, this angle is 60 degrees, so then this will be how much? This is 0.75, so this is 0.75 cos of 60 degrees, right? So we will write 0.75 cos of 60 degrees, right? And this will be equal to 0. Now when we simplify this equation, so then this T comes out to be 99.5 newtons, right? So this is the tension T which is required to hold this OA bar in its position, right? And now if we apply the summation of forces along x equals to 0, right? So then as we can see that this OX is acting in the positive x direction, so we will write OX. Similarly, this cos component is acting in the negative x direction, so we will write minus T cos of 33.7, and now T is 99.5 cos of 33.7 degrees, and this will be equal to 0 since there is no other vector acting in the x direction, right? So this means that OX will be equal to 99.5 cos of 33.7 degrees. And similarly, if we apply the summation of forces along y equals to 0, so this OY is acting in the positive y direction, so we will write OY, and this sine component is acting in the negative y, so we will write minus, and now this is T sine of 33.7, so T is 99.5 sine of 33.7 degrees. And similarly, this weight is acting in the negative y direction, so we will write minus 18 into 9.81, and this will be equal to 0. And if we bring these two terms to the other side of the equation, so then this will be equal to this thing, right? So they will become positive. Now when we solve this equation, so OX is 82.78 newtons and OY is 23.79. Since we are asked to determine the magnitude of the reaction at point O, so then if we represent that reaction, so that reaction will be acting like this, right? OX and OY are the components of the total reaction. So let's say that total reaction is O, right? So then the magnitude of O will be equal to OX square plus OY square under the root 2. So then we can say that OX is 82.78 square plus 231.79 square. From this, the magnitude of O will be equal to 246 Newton, right? And if we want to find the angle of this O with the positive x-axis, right? So we can say, if I draw that reaction O, so that reaction O is like this. This is the OX component, and this is the OY component. And let's say that this is the angle of this reaction O with the positive x-axis, right? So if you want to find this alpha angle, so then alpha, tan alpha will be equal to perpendicular, so OY divided by OX, or alpha will be equal to tan inverse, and OY, so OY is 231.79 and OX is 82.78. So from this we get alpha equals to 70.3 degrees, and this is the angle measured with the x-axis in the counterclockwise direction, right? So this is the angle like this, right? So this is the solution of this particular problem.